All right, overview of 0.6.8 Meerkat, rapid between and raster faster. All right, the main changes are to the generation of the LHY microcode. This is what runs on the M2 Nano. The first thing we'll go over is rapid between. Let me load up the controller and hold it. Okay, now if we start this job, you'll see in settings there's now a rapid between. This is on by default in Jog Standard, which is the standard. So now I execute these commands. Now if I go into my controller, which I have paused now, and we look at this, you can see here there is a transition. This turns the laser on. This turns the laser off. This one does N, which breaks out of slow mode and then does this transition and then loads back in. So this is the standard transition here. Here's a quick little rapid transition in LHY microcode. Okay, let's go ahead and clear that out now. Now let's start this job again, but this time I'm going to switch it to Jog Finish to show you the difference. Starting the job, controller. Okay, now when we load up here, here. This is the standard end to the thing is it does a finish command, and then once it does a finish, it does a normal jog in rapid mode, and then jumps back in. So this is the difference between Jog Standard and Jog Finish. It's purely in the LHY microcode. They'll work slightly differently. Just go ahead and use standard all the time. Should be fine. All right, next up we have a change in the protocol. So if we close this down, if we open a channel, channel, open, and we open the send channel, open the receive channel. Then if we start a job, execute, here, you can see the send and receive things. Let me go ahead and pause this. Okay, so what it's doing here is it sends a packet of code and then it gets a response. 206 is okay. But the important thing is the number of status checks between the two. So to show this off, I've loaded up a copy of 0.6.7 to show you the difference. I created a rectangle. I filled it with gray. I added it to a raster operation. I opened the send channel and the receive channel, and let's go ahead and start the job. Now here, you'll notice that there's two packets between this. The reason it is because it's sandwiched. This packet is to check whether or not the controller is accepting packets, and it says 206, so it says okay, sends the packet, then it checks this packet to see whether or not the packet was successfully sent and didn't return a CRC or any other error, and then it repeats this thing. But this doubles up the packets here when 206 says that it's ready to accept the packet and the previous packet was already correct. So this doubled up the packets. However, here we have a single status check between it. We're back in 0.6.8. The reason this is important is for stuttering. The buffer would underrun and you would get stutters. However, with sharing the OK status check between both, it now increases the stuttering ceiling by 42%. This means that if you would previously, in this worst case scenario, if you set the speed to 70, that would be the minimum for stuttering. Now you can set the speed to 100 without any stuttering in this, which is the absolute worst case scenario. So you'll never see any stuttering below 100 now in Meerkat. If you want to see this in action, I suggest you do the same thing I did here with creating a rectangle, filling it with gray with the fill gray command, and then starting it up and starting the raster. While it's rastering, you can type in the speed commands. So if you do speed 50, it will change the speed on the fly. This isn't new in 0.6.8. But it will let you see what the appropriate speed is and how fast you can get your raster to run without damaging your machine or whatever. All right, next up, we have a couple corrections to the wait loop error. Sometimes when it would finish, it would get stuck in a holding pattern because it wasn't checking for the finish signal in the controller status code fast enough, and it would sometimes miss it, which would get it stuck in a wait command and just be waiting forever. Now it is firstly fixed. It no longer fails that. It checks as fast as it can, and if it does happen to miss it, you'll notice that there will be a new button up here that says force continue whenever it's in a wait command. Don't hit it in any case when your laser is actually moving, but if your laser has actually completely stopped and it's stuck, go ahead and hit the force continue button, which will be located here in your controller. Okay, those are the major changes to the controller backend code. Let's go over one of the few changes that I made to some small little aspect here. There's a issue with the way Rotary works. So if you went to Rotary Settings, right, and you turned it on and you set it to 1.5 or whatever, then if you wanted to do an image here and you wanted to raster an image, say if you wanted to use Raster Wizard and you apply, say, gold to it, sure, gold, and you start the job, it needs to scale this for the rotary because the rotary requires it to stretch out. So when you execute it, then it has to actualize, which is going to resample the image again. And then when you execute the actualized image, you'll notice that it has this weird thing where it's down here. This is because this is the actual location of the image relative to the start. So what it did is it changed the image when it sent it to the spooler and scrunched it down. Now doing it like this leads to a series of little bugs like this. Now let me show you the new sort of option that you can do. Let's go ahead and clear this out. Let's go ahead and delete this image. Let's load up a different image. Now the new options you can see in key map. If you don't have the key map settings here, you'd actually do Control plus Alt plus Shift plus Escape, and it'll reset your key maps in case I added something to the key maps and your settings are saved. Okay, the important things here are rotary view and rotary scale. This is to allow you to view it in the fashion that your rotary would see it. So let's go ahead and select this image. I'm going to hit Control F3. Now it stretched this image. Now when I do Alt F3, it does this in rotary view. Now keep in mind, these things are actually squares, but you're viewing it in a scrunched mode. So now when we go down here, we say apply, I'm doing apply gold. Be a little bit off the screen. Now it's applied in gold, and then when we say start job, it's still a scale for rotary because I didn't turn this off. Now it doesn't need this anymore because it actually already is stretched. So now when we start the job, it just gives you the green light from the start. It did not resample the image. It didn't screw anything up. It started running the image here, and it should work more or less. It's worth a shot. I don't actually own a rotary, so if you do own a rotary and you want to run through various things, it would be good to know what works and what doesn't. All right, thanks for watching.